Hello, this is question 1 on Euromechanics AS level paper from Edexcel from June 2022. So you have a point A is 1.8 meters vertically above horizontal ground, time t0, small stone is projected vertically upwards with speed u from the point A, time t seconds it hits the ground. Yeah, speed of the stone when it hits the ground is 10 meters per second. And we are considering the stone as a particle moving freely under gravity, and they ask us to use gravity 10. Be careful with this because we tend to use 9.8 and we usually forget in these questions. We have to find the value of u, so the initial velocity, and the time t, the time of flight. So what is happening is you have particle projected up, is going to go up, is going to go down. The ground is somewhere here, and this point of projection, the point A, is 1.8 meters from the ground. So this height is 1.8 meters. Yeah, the initial velocity is not given. They say is u, and we need to find it, but we know the final velocity here, which is 10. Is 10 meters per second. So this is 10 meters per second, and it's down because when the particle goes down, the velocity is down. Yeah, we need to find initial velocity and the time of flight. So what we are going to do, like in all these questions, is to use Subat equations. Yeah. To use Subat equations, I'm going to write Subat, and I'm going to see what I know and what I need, and I'm going to consider positive. For example, upwards. Yeah, it doesn't matter. You just have to be consistent. And I'm going to consider the whole thing because I know something at the end, and I know the displacement, and I know I need to find the initial velocity. Yeah, so it doesn't make sense to do just, for example, from here to here. Yeah, so the displacement from here to here, if this is the origin and this is down, is minus 1.8. Then the initial velocity is what I need. Final velocity is down, so it's going to be negative because I say positive is up and this is down, so minus 10. Remember the sign of the velocities or the accelerations is just telling you the direction, nothing else. Acceleration is the gravity, is 10 in this case, and is always down, pointing the earth, the center of the earth, yeah, the earth. So it's going to be negative again because I say positive is up. And the time is the time of flight, and at the moment I don't need it. Yeah, it's the next question. So remember, I'm going to go to my Subat equations, and I'm going to pick one that has no t because I don't have t and I don't need it. The one without t from your 5 Subat equations is this one. You have them in the formula booklet. Yeah, this one. So v squared is minus 10 squared. U squared is what you need, u squared, then plus 2 times a, which is minus 10, and times minus 1.8. Yeah, and from here you find two values of u, one positive, one negative. We pick the positive one, which is 8 meters per second, and that's the first part. Yeah, for finding the time, we are going to do the same. So we are going to use the same values, but now we are going to have an equation with t, and for example, let's say without, we can use any, really. So I'm going to use another Subat equation to find t. Yeah, so for b, I can use, for example, v is u plus 80, just because it's the simplest of all of them. So v, final velocity, is minus 10. Initial velocity is what I just found, 8. And then is plus the acceleration, which is minus 10, times the time, which is what I need. And from here, time is 9 over 5, or 1.8 seconds. Yeah, that's my second answer. And then they say, suggest one refinement apart from including the air resistance that could make the model more realistic. This is a very common question. It's usually 1 mark, and they always tell other than air resistance. So you have to have all their answers on your head. I would say every time you work with gravity, I would say a more accurate value of the gravity. I always recommend you that because it's a 100% sure mark. So you are going to say, for example, so more accurate value of G. And it's not just when G they say is 10, still when you are using 9.8, you can say that you can use a more accurate value of G, yeah, because 9.8 is already rounded. I'm going to show you what you have in the mark scheme. So in the mark scheme, they accept things like this one. So a more accurate value of G, wind effects, allow the spin of the stone, the dimensions of the stone, shape, size of the stone, or variable acceleration, yeah? And they remind you that you cannot answer air resistance, yeah? But all of these answers could be correct. I just recommend you this one because it's always the case. And then in reality, the stone will not move freely under gravity and will be subject to air resistance. Explain how this would affect the answer to part A. So this question is one question that appears over and over, and you tend to make mistakes with it because you think if I have air resistance, the ball will go slower. Yeah, so this velocity will be lower because I have air resistance. But no, because what you know is the final velocity. Yeah, so they give you the final velocity. So for the ball to touch the ground with the same final velocity, if it encounters a resistance on the way, that means you have to project it harder. Yeah, so your velocity of projection must be higher so it reaches the ground with the same speed. Yeah, that's what you need to say. So your initial velocity must be higher. I have another question in the channel where you can see that even Edexcel in the mark scheme acknowledge that many people does that mistake. So everyone says you must be smaller because you have a resistance, but no, it's higher for that reason. You must be higher to reach the ground with the same speed. If there is a resistance, yeah, something like that, if we count the resistance. And that's all. That's all with this question.